Hello everyone, welcome to my channel and this video. Just a quick heads up, this video was originally created in the legacy version, maybe ASP.NET 5 or 6, but the good news is that it can be easily worked upon in ASP.NET 8 or ASP.NET 9. Just follow these steps. The three-step process is: first you create a new project in the latest version that you choose, ASP.NET 8 or 9 in Visual Studio or Visual Studio Code, and just update the NuGet packages from the NuGet package manager, and you can still keep the startup and program file from the GitHub repository, which is the link of it is in the description below, or you can create a single program file using minimal API if you have got experience in that, and that's it. The program is compiled and built, and so let's dive in.
We will discuss the problem with traditional architecture and what is CQRS, or which is command query responsibility segregation pattern all about, and then the solution that the CQRS provides to overcome the disadvantages of traditional architecture. So what is CQRS? CQRS is the short form of command query responsibility segregation, and it's a design pattern that separates the read and write operations of a data source. And the command refers to a database command, which can either be an insert, update, or a delete operation, or it could be a query, which stands for querying data from a source, such as a simple select operation. So implementing CQRS in your application can maximize its performance, scalability, and security. So what is the problem that the CQRS solves? Now this is the diagram which will show you the conventional presentation layer, and it has got this validation and business logic and data access, and we have got the insert and updates, which is a data read write operation, okay, and the queries which is being fetched as SQL statements, select statements, which is retrieving the data, which are queries, and this is the data source. Okay, so here we see this is the traditional architecture. It is that the same data model is used to query and update a database, and it's very simple and works well for this basic CRUD operations. But in more complex applications, this approach can become unwieldy. Why? And let's see an example. For example, on the read side, the application may perform many different queries returning data transfer objects with different shapes. Now, object mapping can also become complicated. And on the write side, the model may implement complex validation and business logic. As a result, you can end up with a very overly complex model that does too much. So there is also often a mismatch between the read and write representations of the data, such as additional columns or property that must be updated correctly, even though they aren't required as part of an operation. And data contention can occur when operations are performed in parallel on the same set of data. So data contention means, when two operations are being performed at this simultaneously from two different machines on the same set of data. One set is doing a read operation, another set is doing a write operation, then data contention comes into being. So as per Wikipedia definition, in database management system, block contention, or which is also another name of data contention, they refer to the multiple processes or instances competing for access to the same index or data block at the same time. In general, this can be caused by very frequent index or table scans or frequent updates, or like what we said, that update and retrieve operation, query and command operation being done at the same time parallelly. Okay, concurrent statement executions by two or more instances may also lead to contention and subsequently busy waiting for the process without the lock. Now, the traditional approach can have a negative effect on performance due to load on the data store and data access layer and the complexity of queries required to retrieve information. And also managing security and permissions can also become complex because each entity is subject to both read and write operations, which might expose data in the wrong context. So here is the solution. Now this is the solution. So what it does is, this is through the CQRS. You can say this is the within the data, this is the data source, it's a read model, and there is a write model. It's different models. Now CQRS separates reads and writes into different models using commands to update data and queries to read data. Now commands should be task-based rather than data-centric. So what is task-based? Task-based means book a hotel room and not set reservation status to reserved. So set reservation status to reserved is a data centric, whereas this former approach of book hotel room is a task centric. So commands may be placed on a queue for asynchronous processing rather than being processed synchronously. And so you can see that here this validation commands and domain logic, and there is a data persistence layer which addresses the data source. This is the data source, which the read model is separated from the write model, and read model generates the queries, generates the data transformation objects, and this is the write model which persists, which saves data on the database. Okay, so queries never modify the database. A query returns a DTO that does not encapsulate any domain knowledge. Okay. So let's now switch over to our task at hand, which is building the product microservice. We'll continue from the part 2. So let's switch over to Visual Studio